In lesson 5.4, we are going to look at the products and the quotients of rational expressions. If you remember, product means multiply, quotient is division. So we'll take a look at some division examples on this slide. So what we need to remember about division with fractions is that instead of dividing by the fraction right here, we always multiply by the reciprocal. So if you remember, the reciprocal is when you take a fraction and you flip it, and we always flip the second fraction. It's always the one following the division sign. So our first step is just going to be to rewrite the problem. We have 4/5. Instead of divided by, we're going to multiply by, and then the reciprocal of the second fraction, 15/8. All right. So now we have two options. We can multiply straight across and then reduce our fraction, or we can do some cross reducing. With numbers, I like the cross reducing. It just makes everything a little bit smaller. So for example, the 5 and the 15, I can divide them both by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And then I notice with the 4 and the 8, I can divide those both by 4. 4 divided by 4 is 1, 8 divided by 4 is 2, and then we just multiply our leftover numbers. We have a 1 and a 3 on top, so that is 3 over 1 times 2 in the bottom is 2. And we have a reduced fraction of 3/2. So that's just a basic example with just your regular old fractions. Now let's get into an algebraic fraction. So again, what we want to notice is we have division, so that means we're going to flip the second fraction. Rewrite it, so we're going to do 6xy over a squared. This turns into multiplication, and then we have a cubed x over 3y. Alright, so the way that I approach these problems is I take a look at the coefficients. If you have coefficients, those are ones where you can go ahead and do some cross reducing. 3 and 6 can both be divided by 3, so 3 divided by 3 is 1, 6 divided by 3 is 2. And once I take care of that, then I just multiply straight across with the problem so that I can get one fraction to reduce each variable within the one fraction. So we have a 2. Here's this coefficient. There's nothing to multiply it with over here. Then if we go alphabetical, the a cubed comes next. And then I can see we have an x times an x. So x times x is x squared. And then we have this y. No y is to multiply it with, so the y just goes there. On the bottom, our coefficient is a 1, which you can write the 1 or not write it. But then you have an a squared times a y, which is just a squared y. Alright, now that we have just one fraction, we're going to simplify this just like we've done in all the previous lessons, just left to right. So first you have a 2, there's nothing to divide it with on the bottom, so the 2 is going to stay. And it's going to stay on the top. Then I can see that we have a cubed over a squared, so when you divide the same base, you subtract. And you're going to get a to the 3 minus 2 as first power, so that stays right there. Then we have that x squared. There's no x squareds for that to simplify with, so that stays as an x squared. And then we have a y over a y. If those are the same base with the same exponent, you can just cross those off. So it looks like we didn't end up with anything in the denominator of our fraction, so I'm just going to go ahead and rewrite. Our final answer is 2ax squared. Alright, our next example has division with 3 fractions. So what I'm going to do is just go left to right. I'm going to do the first division first, and then I'll bring down the third division and we'll take care of that. So first we have 4r s squared over 45. Instead of dividing, we multiply by 27r over 8s. So here I would look for any cross reducing. I can see we have a 45 and 27. I can divide those both by 9. 45 divided by 9 is 5. 27 divided by 9 is 3. I can also reduce the 4 and the 8 with dividing by 4, and I get a 1 and a 2. So now I'm going to multiply straight across. 1 times 3 is 3. R times R is R squared, S squared, over 5 times 2 is 10, and then there's just an S. So, can we do any simplifying with this before we continue on in the problem? And we can reduce the S squared over S. So we have 3R squared. We subtract our exponents when you divide the same base. 2 minus 1 is 1, so we have S to the first power. And on the bottom we have a 10. Alright, so we just did the first division right here, and it gave us 3R squared S over 10. Now I'm going to bring down this division problem. So we're going to divide by 9RS over 10. Because it's division, I can go ahead and change that to multiplication and flip the fraction right now, just so I don't have to rewrite this several times. Alright, look for any cross-reducing with the coefficients. I can see we have a 10 and a 10, so if you divide those both by 10, you get a 1. The 3 and the 9, divide by 3, you get 1. Divide by 3, you get 3. Multiply straight across. On the top, we have just an R squared S. On the bottom, we have a 3RS. Alright, so when we simplify this, the 3 does not have anything to simplify with on the top, so that's going to stay on the bottom of our answer. And then we have an R squared over R, so you keep your base of R, subtract 2 minus 1, you get R to the first power. And then those S's cancel out. So we end up with R over 3, which I'll just rewrite so it doesn't look weird like that. Alright, next problem. Again, when you have multiple operations, just go left to right with it, as long as it's, this multiplication and division will go left to right. If there's addition and subtraction thrown in, that's another story, which we'll talk about another time. So I'm going to rewrite the problem. We have, well, actually, 3xy over xy. I'm just going to go ahead and cancel those out right there, because x over x cancels, y over y cancels. So I have 3 over 1. Instead of the divided by change to multiplication, don't forget you have to flip the second fraction, so y squared over 6x squared. Alright, look for any cross-reducing with your coefficients. You can divide the 6 and 3 by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Multiply what you have left. You have y squared over 2x squared. Alright, if we continue to look at the problem above, we can see there's multiplication, so I'm going to say times. We don't have to flip anything with multiplication. However, I do see that we have an exponent on the outside. I'm going to go ahead and bring that in before I write the fraction down in our problem. So if you bring in the negative 1 to that y squared, that becomes y to the negative 2 power, because we multiply those exponents. And then if you bring the negative 1 into the x squared, and you multiply, that becomes x to the negative 2. Alright, now we're just going to multiply straight across. Y squared times y to the negative 2 power, you're going to add those exponents. 2 plus negative 2 is 0. On the bottom we have our 2, and then x squared times x to the negative 2 power. Again, add your exponents and you get 0. So, do we remember what anything raised to the 0 power equals? Anything raised to the 0 power equals 1, so that y to the 0 power becomes a 1 on top. On the bottom we have 2, and then this x to the 0 power is a 1, so really it's 2 times 1, which is just the 2. So our final answer is 1/2.